This is Mr. Max with Sankofa Mathematics. So I'm going to share a few tests that I have done with my students. So this is the one for the grade 12s on the first part of trigonometry. So this is like AS level. All right, so we'll call this the memo or the mark scheme. Anyway, uh, the second one that I will be doing is I have uh, another test for grade 11 that I will also share with you that I gave to the grade 11s, and then there's another test for grade 10s that I'm going to share with you. Okay, so most of the stuff, like for the grade 11 one, deals with a collection of topics like similarity, um, topics like linear programming and Venn diagrams. So essentially, it's revision work. Okay, all right, so let's get down to the trigonometry one that I gave to the students today. So the first question says the first term of a progression is cos theta. Then they say where theta is an angle between 0 and a half pi radians. So basically it's 0 degrees and 90 degrees. So hopefully by now you should be familiar with conversion of radians and degrees. Okay, and then they say in Roman 1 for the case where the progression is geometric, so we need to find an r. Okay, the sum to infinity is 1 over cos theta. Okay, so we have to look at or show that the second term is equal to cos theta sin square theta. Okay, so maybe perhaps another thing worth noting, you would see that if I do share this on my Google Classroom, and you can actually download it, I'll put the link below. At the end of the questions, you have a list of formula. So I've only included some. Okay, so perhaps there is also another important one that is always there. So I have got some things on mensuration, and maybe perhaps I'll add some things on trigonometry. Okay, and I'm going to put it here. So it's the square identity, cos square theta plus sin square theta is equal to 1. So we're going to use that as well. Okay, we're going to look at all these other formula when we find the area of a sector, the area length of a circle. We are going to look at those as well. Anyway, let's go back to our very first question. So it says that the form or the progression is a geometric progression. So we know that our first term, in this case, our first term is cos theta. We also know that we are given that the sum to infinity, remember the formula for sum to infinity is a over 1 minus r. And we are told that the sum to infinity is equal to 1 over cos theta. So that means we're going to say that I know that a is equal to, so our a is cos theta, so it will come here, okay? And we will know that it must equal to that. So when I'm going to write it down, I'm going to say that cos theta over 1 minus r is equal to 1 over cos theta. Okay, this is information that we are given. From here, perhaps you can cross multiply. So cos theta times cos theta will give you cos square theta. Okay, and then you have 1 minus r. So cos theta times cos theta gives you cos square theta. Anyway, we are looking to make r the subject, so r equals to, and it's going to be 1 minus cos square theta. So let me just take you back to what I was talking about. I was talking about cos square theta plus sine square theta equal to 1. Then if you make cos or sine square theta the subject of the formula, I hope you are familiar with your Pythagorean square identities. So sine square theta equals to 1 minus cos square theta. So if that is the case, then we are going to then replace this this whole of 1 minus cos square theta here by sine square theta. So that gives me that r therefore is equal to sine square theta. Okay, now that we have that, we are going to find our second term. Remember, the formula to find the second term is nothing but t sub n equals to a r n minus 1. So you're going to use that formula in order for you to find the term, maybe the second term in this case. So that gives me that the second term is going to be whatever is the first term, and we know the first term is cos theta. We're going to multiply that by the r, in this case, which is sine square theta. And remember that it's going to be 2 minus 1. So that gives us that the second term is equal to cos theta sine square theta. That is actually what we're given, and that is what we are getting. Okay, another thing also worth noting is from time to time you have to know exactly how these things are marked. Okay, so we're going to have independent mark. So an independent mark is given for this realization. So perhaps I will put here. So for this realization, you get an independent mark. So this is here. It's going to give you an independent mark for realizing that. And then you're going to get a method mark. So a method mark already comes from this application here where we calculated the R. Okay, so this is then giving you a method mark, and then obviously you get an A mark for this final answer. But remember, this answer is given. Okay, but you can only get that accuracy mark. Then you have to make sure that the detailed working gave us this result. So if the detailed working did not come and give us this result, therefore you can't just get a mark there because this is already a given scenario. Okay, let's then go to the second part of the question. They say, find the sum of the first 12 terms of the progression for theta equals to, I'll just write theta equals to pi over 3. It's the same thing. And then we give our final answer correct to 4 significant figures. Right. So S sub 12, so we have to use the S sub n formula. Remember the S sub n formula, when you are using it, you're going to have, perhaps I need to write it down, but not that you're going to get a mark for that. Just to write it down, S sub n is a geometric progression. So it's A, then it's 1 minus r raised to the power of n all over 1 minus r. Okay, so S sub 12, our A from before is cos theta, but our cos theta is now, or our theta is pi upon 3. Then I'm going to introduce square brackets. So this is going to be 1 minus, and then you have in here sine square, and our angle is pi upon 3, and this should be raised to the power of 12. Okay, and all of this comes over 1 minus sine square, and our theta again was pi upon 3. Okay, so you must make sure your calculator is in integral mode, and then you can actually calculate that. All right, so I'm just going to keep that nearby, and then I grab my calculator so you can see how you're going to enter certain values on the calculator. So I'm going to do it step by step. So first of all, my calculator is in degrees mode, so I must change it by going to the setup. I'm going to change it to radian mode, okay? Because the angles is given in radians. All right, so I have got cos in bracket. I have got, you can say pi over 3, but I'm going to put pi over 3. Doesn't matter if you were to put 1 over 3 and then pi next to it, but this is also going to do. Well, I'm just going to find what that answer is. So that is a half. So I'm going to go and say, okay, So that is 0.5. I hope you follow. And then I'm going to bring in my bracket. So that's 1 minus. So I'm going to show you exactly how to do the square ones. Okay. So 1 minus. So now I'm going to look at this one here. So I'm going to come to my calculator and I'm going to say, okay, I have got sine. Perhaps I put the whole thing in bracket. I say sine. So it's going to be pi over 3. Okay. Close the bracket. Okay, close the bracket. The whole thing should be squared. So that's how you can represent that. Sine square theta, you say it's sine theta times sine theta. That's basically what it means. So sine theta or sine of pi upon 3 times sine of pi upon 3, that is how you write it. You're going to get an answer of 0.75, okay, which is 3/4, 0.75. So that gives me 0.75. So I'm going to write here 0.75. But remember, it must still be raised to the power of 12. Okay, and this is going to be 1 minus, we already know what sine square theta is. It was 0.75. Okay, now again, let's grab our calculator and let's work out what our numerator is divided by our denominator. So in any case, our answer for this whole thing, I can go ahead and I can say, okay, so I have 0.5, open bracket, 1 minus, open bracket, 0.75, close bracket. It should be raised to the power of 12, okay? And then I'm going to close the bracket again, and this should be divided by 1 minus 0.75. Okay, so I'm getting that number there, 1.93. You can see that. So the answer is 1.93664. Okay, 72. Just make sure for 7296. Okay, 7296. And then remember from our previous instruction, we are told to give the answer correct to 4 significant figures. So 4 significant figures, this answer would be, just change the color. So that's 1, 2, 3, 4. It will be 1.937. So this answer is correct to 4 significant figures. And this is the solution to the question there. Okay. Right. It's quite a mouthful. So let's come to part B of the question. Now they are saying for the case where the progression is not geometric anymore, but for the case when the progression is now arithmetic, you have to find the first two terms are still going to be, so term 1 is still cos theta, term 2 is still cos theta sine square theta. Okay, and theta now is given to us as pi over 3. Now, again, that is 60 degrees. Okay, so if you were to look in degrees, remember that is 60 degrees. So just for those of you who don't know what pi over 3 is in terms of degrees, you multiply it by 180 over pi, so it's 180 divided by 3, and it's 60 degrees. Anyway, just to have an idea. Okay, so my calculator is still in radian mode, so I'm still going to go on with that. So in order for when the progression is arithmetic, it's an AP now, there is something called the common difference, and the common difference is calculated by taking the second term. Okay, so we take the second term, we subtract the first term from it. Okay, so it is nothing but the second term, which is cos theta sine square theta minus cos theta. But we know what theta is, so our theta is nothing but cos of pi over 3, which is like the 60 degrees, times sine of pi, and I'm just going to write it again so you can know how to put it in a calculator. Okay, so I'm going to have sine pi over 3 All right, this whole thing here should be squared, okay, because remember you have sine square theta is nothing but sine theta times sine theta, okay, which is nothing but sine theta all squared if you put it on a calculator. Anyway, minus cos, and this was pi over 3. So whatever this answer is, this is going to be our D. Okay, so we can grab our calculator, we find our common difference. So our common difference, grabbing our calculator, just clear that previous display. So we have got cos, and here our angle is pi over 3, and that should be multiplied by, I'm gonna go and say sine, and that is pi over 3. Okay, we close that, and all of that should be squared. Okay, and then we're going to minus that business by cos of pi upon 3. Okay, so we're going to get an answer of 1 over 8. In fact, let us just make sure about our calculation, okay, because I want to do it step by step. So what I'm going to do is I'm going to see that was square. I just want to know what that answer is before I bring in the other one. So we're going to do delete this. We're going to say, let's just find cos pi upon 3 times sine square pi upon 3. Okay, so that is giving me nothing but 3 over 8. So this one here is 3 over 8. And then I'm going to bring in cos pi upon 3 just to make sure. So that's cos pi, okay, cos pi over 3. See what that gives me. I think it's better if you do it step by step, so you get a half. So that's a half. And obviously, when you say now 3/8, let's bring our calculator back. So 3/8, take away 1/2, you get a negative answer. Okay, so that is negative 1 over 8. So this is negative 1 over 8, which is what my D value is. Now we have our D value. So the question asks us to find the 85th term. So we need to find the 85th term. So in order for us to do that, we're going to use the formula, okay? And remember, the formula that we use is nothing but T sub n equals to A plus n minus 1 times our D. All right, so the 85th term, our first term happens to be cos theta, and our theta is pi upon 3, and this is going to be 85 minus 1, and our common difference is 1 over 8. Okay, so let's just see what it all gives us. Again, if you have to calculate, remember this is a half, cos pi, cos pi upon 3 radians. Okay, calculator should be in radian mode, and that's equal to 0.5 or half. Okay, so this here is a half, plus this is 84 times negative 1 over 8. Okay, so it's a matter of just calculating and seeing what that gives us. All right, so just try to show you working step by step, and in this case you're not going to make unnecessary mistakes. So it's a half plus 84 times negative 1 over 8, and that gives us our 85th term, which in this case is negative 10. Okay, right, so again you are getting your method marks in there for your common difference and also for using the correct formula and substitution into the correct formula. All right, that brings me to the second question that I have over here. So you have got here a tangent graph, Okay, now when you are looking at this question, you should also have a general idea of the tangent graph. Okay, and I'm going to look at, suppose we have our tangent function, and this is our, say, our Cartesian coordinate system. You know that our tangent graph is going to be anything but something like so. Okay, so this is the origin. Can you see that? The origin is over here. So there are many things that you have to look at. So first, let's look at what is our value of b. So if you look at this particular graph that is given to us, remember this here is pi upon 4, and pi upon 4, for those who don't know how to convert it to degrees, you will say pi upon 4 times, you have 180 over pi, then this is going to give you, okay, so changing it to degrees, okay, the pi is cancelled, is 180 divided by 4, okay, and then, well, you can say half of 90 anyway. It's going to be 45 degrees. In fact, let's use the calculator to show you how to convert. All right, so I want the answer to be in degrees mode, and I haven't done it in a while, so let me just make sure that our setup or our display here is in degrees mode, and degree here is 3. Okay, so now you can see that is in degrees mode. So what I want to do is I want to change shift pi over 4 radians. Okay, I want to change that to degrees. So I'm going to say shift, and I'm going to come down under here. We have DRG, that's degrees, radians, and gradients. And what that is was radians. So that answer is radians, and it gives me now 45 degrees. So when you are using this button on your calculator, just make sure that whatever you want to change it to should be in the display there. And then you choose, obviously, like I had pi over 4 radians, and I want to know what is that equal to in degrees. Okay, because some of you might be a little bit more sort of comfortable using degrees, but in this case, when you're an AS level student or you're doing A level, you should just be comfortable working in radians as well. Okay, so I'm just going to go ahead and put it back into radian mode. Okay, so this whole graph here, what I was now trying to explain, the normal tangent function obviously is at the origin, but you can see that this whole graph has moved. Okay, so it is moved on a horizontal, it has moved by a whole 45 degrees, or a whole 1/4 pi radians. Okay, so that horizontal. So if I was to write down this equation, the function here, y equals to a, and then you have tangent of x minus b plus c. So what the value of this whole business here indicates, this one here, it's indicating the horizontal, okay, translation. The whole graph has translation, has sort of shifted. It has shifted to the right, and it has shifted to the right by what? By 45 degrees, or by pi over 4. So that therefore means that the graph, or the value of b is nothing but pi over 4. Okay, so that was the stuff, and I hope you have also looked at my other video or that I did on transformation of functions, when I said that this here, the stuff here, is then the one that translate the graph to the left or to the right. If this is a minus, it goes to the right. If this was supposed to be a plus, this whole graph would have been translated to the to the left by about the x-axis. All right, so another thing worth noting is that C. And that C is nothing but your other translation, the vertical translation, that sort of stretch, if you want to say it. All right, so let me just bring in another color. So this value of C here, this is the vertical translation, okay? Translation, or sort of stretch, okay? Sometimes can be compressed depending on what that is. So if you now look at the original graph, okay, now we're going to look at it with respect to the distance that it goes up with the y-axis, okay? So you can see that it normally would be obviously at the origin, and now can you see that it is now here now, so which means the whole graph has been lifted up by 1. Can you see that? It sort of went up by 1. So it did went to the right by pi upon 4 radians, and then also went up because where you can see now it's cutting at 1 here as opposed to be at the origin. Okay, because the original thing would have been something that went something like in that area. So we went up by 1, so therefore the C value can also just be determined, all right, and our C, so it went up by a whole 1. So therefore our C is positive 1. So let's now go back and write down what we have. So now I know that y equals 2, and it's tangent of x, and our value of b is pi over 4 plus 1. Okay, now in order for you to calculate the value of a, in order for us to calculate the value of a over here, okay, just come back. So to find the value of a, we are going to do substitution. That means we're going to go into our graph and we're going to determine any point, okay? So the point I'm going to use will be this point here, okay? You can use any other point, but I like to work with this point so that I can substitute. So the coordinate of this point is 0, comma, -1. Can you see that? That's that point here. All right, you could have used any other point on that graph in order for you to find the value of a, but I'm going to use 0, -1. It's much easier, and I'm going to substitute that point into the graph in order for me to find the value of a. Okay, remember, again, don't make a mistake. This is the x coordinate and that's the y coordinate. So -1 equals to a. Then you have the tangent of x being now 0 minus pi upon 4 plus 1. So you have got -1 equals a. Now this is nothing but tangent of negative pi over 4 plus 1, which you can actually calculate. Okay, but first I'm going to get rid of this one here. So that's -1 minus 1 equals to a tangent of negative pi upon 4. Okay, there's a negative angle there. So let's see what it gives me. All right, so here I have -2 equals to a. Then bring my calculator back. So it's going to be, it's in radian mode. So it's tangent of negative shift pi over 4. Anyway, that should give me a -1. So that value is -1. So this here is -1. So therefore, from here, you have a will be -2 divided by -1. And the value of a, therefore, is nothing but 2. Can you see that? So now it means, see if I do have space. All right, so I can go back. So my a value is obviously a equals to 2. That's the vertical stretch. Okay, so now we can actually write our final answer, and we can bring in our final answer. Because I'm running out of time, you can say that a equals to 2, b equals to pi over 4, and c equals to 2. Okay, now c equals to 1. Okay, just to correct that. So c equals to 1. So this here is the final solution. So each one of these is an independent mark. You get a mark for the a, you get a mark for b, and you get a mark for c. And make sure that that b is given in pi upon 4 as radians, because everything here, the domain was given to you as radians. Okay, so that takes care of that question. So we come to question 3. Maybe I'm just gonna minimize it so that you can also read this question well. So again, this is circular geometry, and quite important that you understand circular geometry as well. Okay, right. So again, I said this is my part 1 of my tests because the other stuff is still coming, sketching of graphs, identities, trig identities, and so on and so on. The diagram shows a sector CAB. So CAB, the whole thing is a sector, which is part of a circle. The center is C. So that means that CB, from this information, CB equals CD, which equals AC, because they are all radii, okay, of a circle with center C. Then they're saying a circle with center O, another one here, and a radius r lies within the sector and touches it at DE, it touches it at D, E, and F, where COD is a straight line, and angle AC, where the ACD is pi radians, as you can see by that little arrow. Find CD, you hold CD in terms of R. Now, I already said that this here is R, and that's a radius, so this here will also be R, because this is the center of another circle, and that distance is equal to this distance. So, in a nutshell then, we need to find the distance of OC. All right, in OC, remember also another thing, this here is a right angle triangle because this is just touching the radius there, and the angle that formed by that tangent there with that radius there is 90 degrees. So I have got a right angle triangle there. And I now have to find the value or the distance of OC. All right, so let's just bring that in. So you have got a right angle triangle. Perhaps I'll just draw it here, just to bring in perspective. So that's my 90 degrees over there. This is CO, which we are supposed to find, okay, and this is F. Then O to F, then maybe I can fill in the missing information. So this here is an angle, this is theta, radians, and this is R. So CO is nothing. If you look at how do you find CO with respect to using our ratios, we have got opposite over the hypotenuse. Okay, so the opposite over the hypotenuse, so let me just write here, find CO. So CO will be sine theta, which is opposite, or it's going to be R over CO. Okay, so from here you just have to write CO in terms of its own. So it's a CO, the distance there, times the sine of theta equals to R, and CO equals to R divided by sine theta. So if that is the case, that this distance over here, the one that I mark, is R over sine theta, okay, then the whole long distance over there, so this is, so now to find CD, I have to add the 2. I hope you can see that. All right, so CD using using R and sine theta, CD is going to be R plus R over sine theta. Okay, again, it doesn't matter which one you write first, whether you write R over sine theta plus R. So that is the distance of CD, the whole one over there, the whole distance C to D. Any case, then that's going to be the same distance for CA or AC and BC. All right, that takes me to the next question. Now, it is now given that R is equal to 4 and theta is equal to pi upon 6. Again, that is 30 degrees for those of you who want to know what that is in degrees. Okay, so they want us to find the perimeter of sector CAB. So let's just make sure that you get the understanding. The perimeter of CAB. So it is the whole CA, then AB, then BC. All right. So first I'm going to find arc AB. All right. So an arc length, and again, you can look at the list of formulas below the question paper. So first of all, let me say what is the radius. The radius of arc AB, remember the radius of arc AB, which is this whole, I'm looking for the radius here, is this whole distance, which is CD, which is what we calculated, is going to be what we have from there. Now they say R is 4, so it's 4 plus, then it's 4 over sine, and we have got pi over 6. So this can be calculated in any case. So that is 4 plus, grab your calculator again, and let's find out what is. Calculator should be in radian mode. So it's 4 over sine, is it pi upon 6? Okay. If you're using degrees, then I'll suggest that you change everything to degrees, even your angle, you still get to the same answer though. Pi upon 6, again, that's 30 degrees. So the answer is 8. So here you get 8. So the radius then is 12. Okay. 12, I believe, centimeters or 12 units. All right. Good. Now we know what the radius is of that arc. So now we have to find the arc length. So the arc length, arc AB, remember, arc length is calculated using, obviously, using the formula theta times r, or the other way around. Okay. But here's the thing. I'm looking for arc AB. And I only have my theta over here. So this here also will also be theta radians. You agree? So this whole thing in a nutshell will be theta plus theta, which must give you 2 theta. So that whole angle ACB, angle ACB should be 2 theta. So when I'm using my formula over here, okay, I have to say, recognize that we are looking for that whole angle there, because we have got the arc length. This is what we are trying to find. It's a horrible drawing, but you'll get my understanding now in a minute. So we have got, this is 12 over here, that's 12 over here, this here is 2 theta, and we are looking for this length here of AB, arc AB. Okay, so you see, what is that on top? Is it a C? Right over there is a C, so that is going to be C over here. So we are told what we are supposed to use for theta. So our theta is pi upon 6, so we're going to put pi upon 6 over there. All right, so then we're going to calculate, okay, multiplied by the radius, which is 12. So that means this is going to be arc AB is equal to 2 times, so it's pi over 6, all right, times 12. All right, so that is nothing. So grab your calculator, because remember, we're going to leave our answer in terms of that. Okay, so whatever this answer here is going to be, so it's going to be, let's clear the display, 2 multiplied by pi upon 6, which is pi upon 3, and we multiply that by 12, and then we get 4 pi. All right, so this is 4 pi. So anyway, this over here is 4 pi. So now we can actually calculate we can calculate the perimeter. Okay, so the perimeter, because the question wants us to find the perimeter will be nothing but 12 plus 12 plus 4 pi, and the answer is 24 plus 4 pi. Okay, again, you must leave your answer in terms of pi. Okay, so you get a mark for that. Says leave your answer in terms of pi. All right. Okay, that brings me to part C of the question. Now here they want us now to find the area of the shaded region. Now there are many ways you can do this, okay, many different methods. So again, you have to decide which method works the best for you. So let's just go back to our diagram just to see. So we're looking for the area of the shaded region. So I can find the area of FOC. So I'm just going to bring that drawing. So if I could see, so please, the drawing is going to be rather uh, horrible. So it's going to be, yeah, it's quite something. All right, so let's suppose that is our circle over there. Okay, it's quite a nice drawing. Let's just make sure we get everything in order. The key is touching. It's touching. So would have been nice if I could have somehow also drew it here again. But anyway, okay. So what they are looking for is this area over here. All right, that area over there. So if you were to look at the diagram, and if I was to draw something from here all the way up to there, all the way up to there, okay, you must understand the drawing is not perfect. It's supposed to be touching like so. And we also know that this is the radius of 4. That's the radius of 4, and this is also radius of 4. Anyway, in my diagram, which is quite interesting, so I'm going to quickly bring in a picture. Let's just clean this up because it doesn't look so nice, and I don't want to use the diagram that I had before. Oh, I can do that perhaps. So let's see. Okay. Just bear with me. Technology. Okay. We're going to insert an image. The image that we're going to insert, see from our desktop. I'm going to go to the test. Yeah. Let me just grab that image. See if I can do it in such a way where I could paste it. Anyway, there we go. I think it's now better. So we don't have a problem. Good. Thank you for bearing with me. So, because I want to find the area there, and I don't want to really do all of that stuff over and over, okay? Right, so let's see. Let's write what we have. So I am saying here, I'm going to say the area of FOC. Now, FOC. Remember what is R, okay? And we're looking for the area of FOC. So I'm using the formula a half times 4 times 8. Remember the 8 comes from, it's going to be this distance CO, right? Times 8, and then times the sine of theta. But we know that according to the information, our theta that we have to use is pi over 3. So because I'm using this theta here, this also will be theta. But I'm just looking at this one. So the whole thing here was pi upon 6. So if you divide that, so we're gonna find that little angle over there, and that little angle is nothing but pi over 3. Okay, pi over 3. So again, remember, we're just working with this triangle over there, okay? Because I want to use that triangle over there, and I'm using the formula to calculate area of a triangle. I've got two sides, and I have two sides, like this is 4 here, and this is 8, okay? And I have an angle. That is actually what I need to make sure. I have an angle in between, so this angle that you're seeing, is pi over 3. So this little angle over here, so just highlight it, this little angle over here, this angle over here is this little angle over here. Okay, that's pi upon 3. And also another thing, this is here, this is 90 degrees, or this is half pi radians. So that's 90 degrees. So if I want to find this angle here, I know what this angle was. Okay, so remember that 60 and that angle is 30 degrees, and 30 degrees is nothing but pi over 6. All right, so that was pi over 6. So for me to find this angle here, I would say, well, just take that pi over 2 minus pi over 6. All right, so that's 6 pi minus 2 pi over 12. Well, that is going to give you 8 pi over 12, and then you can go ahead and simplify that. Okay, just make sure that we are on the right path. Okay, let's bring in our calculator. So I'm looking for this particular angle over there, and our theta from before, our theta is pi upon 6. All right, theta is pi upon 6. So we're going to take shift pi over 2, pi over 2, that's 90 degrees, minus shift pi over 6, pi over 6, that's 30 degrees, and that gives us a third pi. So this is how I get this angle here, which is a third pi, okay, which is a third pi. Good, hope that makes sense to you, because this little working over here could have been a bit confusing. Now, what happened to our drawing? Good. Anyway, I just want to make sure that we do understand the answer here. Let's take away. All right, so there's a little bit of a challenge here. But anyway, the answer here is nothing but pi over 3. Okay, good. There's where that angle comes from. So this is going to give me FOC. Can you see that? Of FOC. So FOC, if you punch that in on a calculator, you have 4 times 8 is 32. Half of 32 is 16. So that's 16 times, you can just put, you don't have to put the times though. It's pi over 3. That is 60 degrees, okay? Pi over 3. So you get 8 pi there, 8 root 3. So that is this sort of sector here. Now, also looking at that, then if I have to bring in the whole, yeah, so the whole area of that sort of kite, you see what I'm saying? I've got the area of this sort of kite. So the area of the kite will be, so I can actually say area of FOEC will be twice the area of what we got from the previous answer, which is 16 root 3. Okay, now we need to find the area of the sector here, the one sector FOE with radius 4. All right, so we need to find the area of this and subtract them from each other. So I'm going to say the area of sector FOE, so maybe you can write it like that, area of sector FOE, and remember the formula It's a half r squared times the angle. So it's a half, and the radius is 4. And the angle now, remember that angle here is pi over 3. So 2 of that, so it's going to be pi over 3 plus pi over 3. Okay, so that whole angle there is now 120 degrees, okay, which is the same as pi over 3 times 2. Pi over 3 times 2, that's 2 pi over 3. Okay, so that gives you 2 pi over 3. Okay, 2 pi over 3, so that is 2 pi over 3. Okay, so everything should be multiplied together. That's going to give me this unshaded sector here. Okay, right, so let's grab a calculator and see what we get as an answer. So I have a half times 4 squared times 2 pi over 3. Good. That gives me 16 over 3 pi. So that's 16 pi over 3. Okay, that's 16 pi over 3. All right, so that's the unshaded region there. So in order for us now to find the shaded region is actually not that the shaded region or the shaded area. I'm going to take that 16 root 3 minus 16 pi over 3. Okay, and that is the final answer because they said we must leave your answer in terms of pi and in terms of root 3. Do not go ahead and multiply it out, okay, because they said leave your answer in terms of pi and in terms of root 3. Okay, so again, there is alternative ways that you can do this. As long as you get to the same answer, you get marks for your method, correct steps, independent marks, and such things. Okay, but you see that you have to physically work with the drawing or with the diagram. There's quite a lot that you put in the diagram, and you need to be familiar with your formula. Okay, so again, look at the formula sheet so you cannot make a mistake when you want to find whether it's the area of an R in a sector, which is part of a circle, or whether you want to find an arc length, that you don't get confused. Okay, question 4 is the last question that I gave in the test. It's also circular geometry. So this one says the diagram shows two circles, and I have C Roman 1, or C, not Roman 1, but C sub 1, it's a subscript. That represents the big circle. The small circle is C sub 2. And as you can see, the big circle, obviously, it touches at the point T, both of them, circle 2 and circle 1, touches at the point T. Circle 1 has the center at P and the radius is 8. By saying that, it also implies that the distance from P, this distance from P to T is 8 centimeters. And also at the same vein, the distance from Q to T is 2 because it's the radius of that. Can you see that? Right. So anyway, then they're saying points R and S lie on circle 1 and circle 2 respectively, and RS is a tangent. It's a tangent to both circles. So it means the angle that is formed here is 90 degrees. Is 90 degrees. Okay? And if that is the case, then this whole one from here, perhaps up to there, will be the same distance. You get it? Of RS. So, having said that, then also considering that from here all the way up to here must be 8 minus 2 because that is 2 over there. Can you agree with me? So this distance here is 6, and that is going to be a right angle triangle. Okay, so now they're saying we should show that RS is equal to 8 centimeters. Anyway, that means we have got a right angle triangle. So I'm just going to write that, draw that drawing here. This is 10 because it's 8 plus 2 more. So that's 10 centimeter. And this is 6 centimeter. and we are supposed to find this distance here. So you can use Pythagoras, okay? So I will call that distance, maybe this is, let me just say x. So x squared, which is the same as our RS, is going to be 10 squared minus 6 squared, okay? So x is going to be, well, that 100 minus 36, which ultimately means that x equals to 100 minus 36, which is 48, and we take the square root of 48, okay? Square root of 10 square minus 6 square, okay? Then it's 8 anyway, sorry. It's supposed to be 64 in there. It's 8. So I was wondering where I got to that answer. Anyway, this answer is 8, of course. So we have actually proven that RS is equal to 8. So if this distance here is 8 over there, then this distance is 8 because it's a rectangle. Can you see that? Good. That's 2 marks for doing just that. Right, so the next question, find the angle in radians. So perhaps I'm just going to work from that diagram over there. Maybe if I can see if I can bring that diagram in. So we're going to find angle RP. Actually, we can just bring in my drawing. So I already have my right angle triangle. I know that's 10. I know that is 6. And I know this is 8. So this is RQ. And that's P, and they want us to find this angle theta over there, okay? Because they say RPQ. Let's go back to our drawing. They are looking for angle RPQ. So it's that angle over there. So you can actually now use any of your trig ratios, because if you are given three sides of a right angle triangle, you can use any of the trig ratios. But remember, this is in radians, so your calculator needs to be in radians. So I'm going to use sine theta equals opposite, in this case it's 8 over 10, or anything equivalent to that. And that angle then is going to be, and you have to use this when you are trying to find an angle. So you say it's in radians, so you say inverse sine of 0.8, or 8 divided by 10. Let's rather stick to 8 divided by 10, and that should give us our angle. And we give that answer that we get, we then give it to 4 significant figures, okay? So our answer there is 0.9 273 radians. So just to make sure that angle RPQ is equal to 0.9273 radians. Okay, let's check again from your 9273 radians. Good. Now they want us to find the area of the shaded region. So again, I'm just quickly going to bring in that diagram, okay, because I don't want to work on the one that I had before. So I'm just going to grab the diagram, and I'm going to copy it over into my working here. All right. So let's see. So what do we know? We now know that just save that. We now know that this angle over here, from our previous work, is 0.9273. We also know that these angles here, just to bring it out, is pi over 2, or 90 degrees, okay? Pi over 2. And we need to find this angle. And we also know that this is a trapezium. So once you now want to find the area of the shaded region, so to find that region, I will say the area of the trapezium minus the area of two sectors. I hope you can see. All right, so if I can find this sector here and I can find this little sector here inside, then I can find the shaded part. All right, so let's talk about the trapezium. The formula to calculate the area of a trapezium. By the way, that trapezium, if you had to switch it around, it will be something like so. This is parallel, so that's going to be 2, that's going to be 8, and this is also 8, which is RS. So if you find the area of this, the formula is simply you add the parallel sides, multiply by the height, divide by 2. Okay, so that's 10 times 8 is 80, half of 80, so it is 40 square centimeters. So that's the area of the trapezium. Now, also what we know, the area of a sector, the formula, area of a sector is calculated by saying a half times the angle times r square. So area of sector, so maybe I'll take the first circle. So the first circle is going to be the angle in the first sector, this one here. It's the angle that we calculated, 0.9273, and the radius there was 8 squared. So that's going to give me the area of the first sector. Okay, and I'm going to come back for the area of the second one. So let's just grab the calculator and see what is this value. Okay, so the calculator is still having that. So I'm just going to say times a half n times 8 squared. So that's going to give me pretty much an answer that I'm looking for, 29.6734. So it's 29.6734. Okay, and so on and so on. So that's going to be, if I have to shade it just to bring your attention, what we now calculated was this area here. That's what we now calculated. Okay, that's what we calculated now. Now I'm going to calculate this little area over here. But in order to do so, I need to find what is that angle. Okay, so we need to know what is the angle going to be. Okay, so we now, if I just come back to my drawing, so if you come back to my drawing, so what I now know is, let me just bring in my work. I know this angle here is pi upon 2, 190 degrees. This one here is also pi upon 2. This one here, from my former work, this angle over here, that angle was 0.9273 radians. So it's a four-sided figure, and all the interior angles, they should add up to 2 pi radians or 360 degrees. So if I want to find angle TQS, I'm going to say 2 pi radians, that is 360, minus pi upon 2 to 90, pi upon 2, and that one over there, which is 0.9273. Okay, right, so that's going to give me an idea, because I need that angle here. That is what I'm looking for. I need this angle over here, all right, in order for me to calculate that sector, that sector there. So again, let's grab our calculator. It's a lot of work, but again, there are so many ways you can do this. So this is 2 pi minus, in brackets, pi upon 2 plus pi upon 2 is just going to be pi, but I'm going to write it down anyway, because it's a half plus a half. Okay, so you must follow, and you should be very familiar of how to work with these angles and things like that. So that's 0.9273. Okay, up to that should be enough. Okay, so I get 2 point, that angle there, 2.21. So let me write it down. So it's 2.214, 292654. 292654. Okay, so that is what that angle is, the one that I have marked here in red. Now, in order for me to find the area of that sector, so to find the area of the sector here, this area of this sector, I'll have to use my formula again, like what I did with the first instance. Okay, so the area of that sector with a radius, the area of sector, I can actually call it TQS. TQS is a half times the angle 2.21429 and so on and so on, times the radius is 2 squared. Okay, that's going to give me the area of that sector. Okay, your calculator, remember, is still in that, still have that angle, so you can just go ahead and say, okay, that angle times a half times 2 squared, which is 4. Well, you get 4.4285, so it's 4.4285. 4285, 85303. Okay, 85303. Just make sure that I got it correctly. 30303. Guess 307. My goodness. Anyway, what I've written so far is in fact even enough in order for me to find 307. Okay, 85 85307. Okay, so that is the area now, that is centimeter square. So what do I have now? Now I have the area of both sectors. I know the area of the trapezium is 40. And so I'm going to write down, you can scroll down with me. So I'm going to write down that the area of the shaded region, the quiet region, is going to be that 40 from the trapezium. Then, since this one is nearby, I'm just going to write it down. 85307 plus the other one is 29 point. Okay, that 29 looks kind of horrible. Let's just make sure it's correct. 29.6734 and so on and so on. And well, that gives you 40 minus. Now the sum of all of this is going to be 34.10 and so on and so on. And I'm going to get an answer of 5.898 centimeters square, and to three significant figures is 5.90 centimeters square. So this is the required answer, and I know it takes quite a lot of work, but you should arrive at that answer. Okay, it's a lot of work, it's a lot of things that you need to show, and you've seen that I went back and forth by working on my diagrams and bringing in the diagrams again just to make sure I don't miss any. All right, so this was the test on trigonometry, and normally what I do is I do give the list of notation and formula that you get from when you write the AS level exams. I just took a few that I thought is relevant for this particular test. I hope you have learned and understood a few things. You can always go back, you can always rewind, pause, and try to do them. Remember I said I'm going to post this paper, also a link to it, on my Google Class. Remove the code in order for you to download it, and maybe you can share it with your students, or you can also attempt to work it out. Okay, good luck with your studies.